My channel, this is a very important question. Maximum width of binary tree, and maximum width of a binary tree is the maximum width amongst all the levels. And what is the width? So width is, if we consider this to be a complete binary tree, then width is the total number of nodes in that level. And a complete binary tree, as we all know, is one where where all the levels are filled and the last level is filled from left to right. Isn't my screen visible? I think it is not. So as we have seen that in a complete binary tree, we have every node at every level is 2 raised to power height minus 1. Like here the height is 1, the number of nodes is 2 raised to power 0. This is a complete binary, and we are talking about all the levels except for last, because last is filled from left to right. So if it would have been a complete binary tree, this node would be there, and the maximum width among this level is 2, among this is 1, this is 4, so the answer would be 4. These are some of the sample cases which are provided in the example. If this would have been a complete binary tree, all these nodes would have been present. The maximum width 1, 2, 4, and the maximum width here is 7. Because this level is not there, we will not be filling it, because we have to find minimum steps required to make this binary tree complete binary tree. And in complete binary tree, this is valid, last level can have from left to right. Here also 1, 2 and 1, so the answer is 2. So one thing is clear, that we have to find the width for each level and then take a max of all of those. And so this is going to be an example of level order traversal, obviously, because her level ka nikalna hai. So we need the level wise data, and most of the questions in binary trees are solved with level order traversal only. Some are solved with DFS, this is BFS, level order is BFS, we use a queue. Some are solved with TFS, which is stack, and in order, pre-order, and they are in order, pre-order, post-order are majorly used in BSTs and non-binary trees. So one property of CBT which we all know is that if the parent node is at I, the left subchild will be 2 cross I, this will be the index, and the right subchild will be here. And this index is required when we are storing this data level wise in an array or vector. So if the parent is present at I index, this is where the left child will be present, this is where the right child will be present. Here this array is 1 indexed. That means I is the first element starts from 1 index and not 0. If it would have been 0, these would be the left and right subindexes, which is 2 cross I plus 1, 2 cross I plus 2, and if this is 1, it is this. How did we get this? So we already all know that every level will have 2 cross I minus 1 number of instances. So here, if there would have been more instances, or here there would have been more instances, the total number of instances would be 2 cross I, and therefore the next element would be 2 cross I plus 1. If there are instances here, there are instances here, this would automatically be 2 cross I, and 2 cross I plus 1 would be the right subchild. So for finding out the width at every level, we will have indexes. So every level width will be left index, right index minus left index plus 1. That will be the maximum width. That will be the width of each level. We will take a max of that. Let us implement, because we have to make a level order traversal. We have to store the indexes and tree nodes. We will make a queue of pair of tree node and the index, and we will also need a max width, which let's say starts from 0, because width will obviously not be less than 0. And while queue is not empty, we will be processing. Okay, also queue will be empty initially, so we will have to push the root, and pushing the root is also important, because that is the first level of that is a node from where we start the traversal, and root, and it will be at least at index 1. We can also sit at index 0. Similarly, the values of left and right indexes will be updated. So let us find out the front of the root, and what do we return? We return the max width. Let us find out the indexes of the left child and the right child by processing all the nodes level wise. So let us find out the size. This is the size, and we will have to traverse over this size, okay, because every time we come here, this queue will be only containing the nodes at that particular level. Now we have found out the size. We will also find out the min, okay, for that thing. Okay, let us take first and last at both 0, and we will, if the size is 0, then we will be updating the first, and if I is equal to size minus 1, we will be updating the last. Let us find out the front. So front will be a pair of 3. We can also take auto and long, let's say call it E, which is q dot front, and we will also simultaneously pop it out because that will make this queue stale. So int index is going to be, sorry, long index is going to be E dot second. So first is equal to index if I is 0, because that is the first in the level, and this is going to be the last in the level. And what will the width be? The width will be last minus first plus 1, and the max width will be max of max width and width. And after this, if the is first left exist, then what do we push? We push E dot first left, and what will be the index? As we have discussed, 2 cross I, which is this. If the right exists, we push 2 cross I plus 1. If the right exists, we push 2 cross I plus 1. There is going to be one, okay. So it worked, but there's going to be one issue, because these indexes, they can exceed long. That could be one of the issues. So yes, because they cannot be represented in type long also, they have exceeded even long, because the tree was super large, and we are multiplying by 2, so it is going to get in powers of 2 raised to power height minus 1. This will be exceeding long very quick, even for a small tree. So and this is like a lot of nulls, so you can see कि नोड्स कम है बट लेवल्स इसने पक्का ज़्यादा कर दिए होंगे. स्क्यू ट्री होगा तो बहुत सारे लेवल्स हो जाएंगे. तो हम क्या करेंगे, नॉर्मलाइजेशन कर देंगे. नॉर्मलाइजेशन हमने मशीन लर्निंग में सीखी थी. तो नॉर्मलाइजेशन कैसे करेंगे, क्योंकि हमें तो वैसे भी डिफरेंस चाहिए. तो डिफरेंस में अगर लास्ट और फर्स्ट को भी मिनिमम से सब्ट्रैक्ट कर देंगे, तो लेट अस टेक फर्स्ट विड्थ विच इज़ q डॉट फ्रंट डॉट सेकेंड, है ना, यही तो है. और नॉर्मलाइजेशन के टाइम पे इसमें से फर्स्ट विड्थ सब्ट्रैक्ट कर देंगे, तो वो 0 से स्टार्ट हो जाएगी ना, और नेक्स्ट वाले तो सारे प्लस प्लस 1 है. तो ये हमने नॉर्मलाइजेशन कर दिया, इससे इन जो विड्थ है उसकी वैल्यू कम हो जाएगी. सो आई होप दिस वॉज हेल्पफुल. थैंक यू, बाय.